Design and Technology, Unit 2, Module 1, Part 4A, Applications of CAD. Objective: at the end of this lesson, students should be able to describe various uses or applications of computer-aided designs, CAD. Introduction. Computer-aided design, or CAD, is a form of software automation that uses various computer-aided design tools to help engineers, architects, and other professionals in their design activity endeavors. It is considered to be both software and special-purpose hardware. The CAD is available in various packages ranging from 2D vector-based drafting systems to 3D parametric surface and solid design modeling. Uses of CAD. CAD is used in major areas for applications that involve computer graphics, computer-aided manufacturing, solid modeling, solving by constraints, and for architectural purposes. Other fields that use CAD applications include Architecture, Engineering and Construction (AEC), Mechanical CAD (MCAD), Electronic and Electrical ECAD, Building Engineering, Manufacturing Process Planning, and Digital Circuit Design. Uses of CAD in design and manufacturing. CAD uses 4 basic phases for designing and manufacturing. These are the requirement phase, which collects the basic requirements and conceives the basic idea; the designing phase, that uses detailed component modeling and assembly modeling; the development phase, which uses engineering drawings; and the manufacturing phase, which utilizes the tool design. Now let's look at storage and retrieval of CAD data. CAD software packages are used to both design and store various components of a product. The design can be produced as either a two-dimensional 2D drawing file or as a three-dimensional 3D drawing file. A CAD program enables designers to generate or create multiple views of geometric designs digitally. The designs can then be stored for retrieval and analysis. How the analysis feature of the program allows designers to retrieve their work, analyze design problems, and produce a digital prototype. Now let's look at modeling and manipulating images. The 3D features of CAD allow designers to model and manipulate various types of geometrical shapes on a computer screen. Now users have the option of creating solid models by manipulating 2D shapes called regions into 3D images. To do this, a 2D CAD image must be formed into a solid either by using the extrude or revolve command. Let's look at those commands at this juncture. As can be shown on the page, we have the extrude command that is on the left, that is used to form rectilinear shapes as well as cylindrical shapes. As you can see, the 2D drawing image is extruded to produce a 3D image. On the right is the revolve command in application. It is quite useful to create a cylindrical solid with reference to a given axis. You can see the axis and you can see the 2D image being rotated or revolving around that axis to create the 3D image shown. Now, instead of extruding or revolving an object, AutoCAD has primitive commands which can be used to create a solid or building block of 3D images. Primitives such as cubes, cylinders, and cones can all be used to start building 3D models. Other types of primitives that exist are sphere, torus, and we see also the triangular prism. Now, creating the desired 3D models requires joining these primitives. Models can be further manipulated by using what are called Boolean operators, such as intersect, subtract, and union. Operations are used on Venn diagrams in mathematics. Now, as the diagram shows, we're seeing where A is union with B. The second diagram, reading from top to bottom, shows you where B is subtracted from A. And the final diagram shows you the intersection of A and B. The results of Boolean operators on solids depict a similar kind of relationship. Other manipulations of 3D drawings include rendering surface areas, creating curves and other drawing features in real time, orbiting a 3D model to allow the surfaces of images to be viewed from various angles, among others. Types of 3D models include 3D wireframe, which defines an object by using boundary lines, 3D surface modeling, which defines an object by using surface boundaries, and solid modeling, or 3D CAD modeling, which defines an object as a solid that has weight, volume, and density. Now let's look at these three images and their features. The wireframe is the first one, the 3D wireframe. This model contains edges and vertices as shown on the diagram, but it cannot represent complex surfaces. Neither does it show details regarding the interior of the part. For these reasons, this 3D wireframe is considered to be ambiguous for interpretation. The second diagram shows you the 3D surface modeling. This model contains edges and vertices as the 3D wireframe does, but also shows you exterior surfaces. This diagram can represent complex exterior surfaces. However, there are no details regarding interior part or parts. And so, for that reason, this diagram is too ambiguous for engineering analysis. This final 3D image represents solid modeling or 3D CAD modeling. The model contains edges and vertices, exterior surfaces, but also provides detail of interior parts. This part shown here is unambiguously defined, and so for that reason it may be used for engineering analysis. Once analyzed and edited, a 3D model, such as the one shown on the right of the screen as an insert, can be updated and stored on the CAD software as a digital prototype for easy retrieval. It can then be shared as a digital file within an organization or firm, either for networking or further deliberation, prior to be moved into production. Now, once approved, the completed drawing can be sent directly into production with the aid of a computer-aided manufacturing software, CAM software that is. This brings us to the end of this presentation. These are my references. Thank you.